Okay, so we were talking about how to measure pressure using this device. Okay, so we have seen that at the same level, the pressure is the same for all points in one fluid. Okay, and since here it's one fluid, it's mercury inside the reservoir and inside the tube, then at the same level we have the same pressure. We know that here it is subjected, let's say, to P atmospheric. So here we have the atmospherical pressure. Now we can say, because the pressure at this level is the same, then the pressure here is equal to the pressure of this point. Now, how to calculate the pressure of this point? To calculate the pressure of this point, we should consider the column of fluid above the point. Okay, so you know that a column of a fluid will produce a certain pressure, and this pressure is given by rho g h, which is gamma h, because you know that we can replace rho g by gamma. Okay, so it is equal to rho g h or gamma h, where gamma is equal to rho times g plus the pressure in the empty space here. In fact, in mechanical engineering, you know that at equilibrium state, you have here what is called the vapor pressure. Because if you have vacuum here, you will not have equilibrium until the pressure in this part is equal to the pressure of the surface of the fluid. So this is what we call the vapor pressure. Okay? So in general, in this part, we will have the vapor pressure of the fluid. But because mercury has a very low vapor pressure, we can consider that the pressure here is nearly zero. And therefore, we can say that the atmospherical pressure will be equal to rho g times h. So the height of the column of mercury will give us the pressure outside. Now, sometimes we don't know what is the pressure in the room. So here we know it's atmospherical pressure. If we have a suction in a room and we want to determine what is the pressure in the room, we can take this device, and this height will change depending on the pressure at this level. So when we measure H, measuring H will allow us to find the pressure in any space. Okay? So this is the concept of the barometer, which will allow us to measure pressure. Now, another type of transformation of energy is electromagnetic induction. Using electromagnetic induction, we can transform magnetic energy into electrical energy, or we can transform electrical energy into magnetic energy. Okay? So in 1831, Faraday come up with some observation, and he stated the following law. First, a current is set up in a closed circuit by a changing of magnetic field, and also in a loop of wire when moved through a stationary magnetic field. What do we mean by this? So if you have a circuit, okay, and you have a coil, if you circulate current, then this current will lead to the formation of a magnetic field around the coil. And in a reversed action, if you have a magnetic field and you relate it to, let's say, a lamp, the magnetic field will be able to, by being reduced, it will be able to transform into electrical energy, and you will have a motion of electrons that can light a lamp, for example. So to see this more, I will show you the following video. On electromagnetic induction. So mainly in this invention, we have seen that we can convert magnetic energy into electrical energy. or electrical energy into magnetic energy. So this is a simple circuit that will show you this. Okay, so here you have a coil, okay, related from one side to a battery and from the other side to a lamp. In this way, okay, if current will flow in the coil when there is a relative motion between the coil and the magnet. So here, for example, if you have a certain magnet and you move it relative to a coil, you can create a current. On the other hand, another way, if you connect the coil to a battery, when you have the current that will go over this circuit, this will create a magnetic field around the coil. Okay, so the wire coil will serve as an inductor since it will induce a voltage in the coil when its magnetic field will change. In this example here, you will see first that inductor will store energy in the form of a magnetic field, because when the electron will circulate in this circuit, okay, now we close the circuit, electron will circulate, okay, this will lead to the buildup of a magnetic field around the coil. So you are transforming electrical energy into magnetic energy, okay? And once you build your field and it is strong enough, then the reverse process will take place. Magnetic energy will be transferred back into electrical energy. So you will see now that energy will be transferred now to the lamp from the magnetic field. Okay, so as we can see here, now we opened the first circuit. Okay, we have built a certain magnetic field that is very strong in the wire. So now the electrical energy will be first, it will split between the lamp and the coil for the first time, and then when the magnetic field is strong enough, we will have a reversed current. So as you can see in the yellow arrow, we will have a reversed current that will lead to the lighting of the lamp. And even if you remove the battery now, the magnetic field will create an electrical current that can light your lamp. So in this way, we can transform energy from magnetic to electrical and then back. So first from electrical to magnetic energy, and then from magnetic energy to electric energy. Okay, so as you can see here, the magnetic field was able to light your lamp. So it will create electrical energy. Now, before continuing the slide, I want also to show you how steam engine works. So we have done also engines. So we will look at a video on steam engines. So here we will see how heat from steam can be transformed into other types of energy. So one of the main applications of steam engines was for transport. Okay, so it was to change energy from thermal energy into rotational energy, mechanical energy that can drive cars and trains. Okay, so one of the first application of steam energy was motion of trains, as you can see here, and you can see that steam is ejected outside. Okay, so this is due to the very high temperature of the exhaust jet. So here we can see a small figure of how it can work. Okay, so one of the simple application of steam engines is to produce, let's say, a translational motion that can shift objects, that can lift objects. Okay, so first we burn coal and energy is released. So we produce steam of high pressure. Okay, now this steam of high pressure will allow to expand this piston in this chamber. Okay, so the piston will go up when we have high pressure, and then when it is cooled down, we have low pressure, it will go down. So by this way, we can transform heat energy, okay, into mechanical energy, because we have here the translation of the piston created by this effect. And we will see in this course that energy can be calculated as integral PdV. Okay, so one of the ways of calculating energy is that energy is equal to integral PdV. Okay, and mathematically this can be done graphically by considering the area under the curve, because you know from math that integral of a function is nothing than the area under the curve. So here, if you draw for this small device the variation of pressure with volume, okay, you can say that the area under this curve is simply the work done. Okay, so this will be the work done by my device, and the heat released by my steam engine is needed to rise the pressure. Okay, so I rise the pressure, then using this mechanism I will convert my high pressure into translation of my piston, producing a mechanical work. Okay, so now let's go back to the slides. So we have seen how we can also transform magnetic energy to electrical energy, and electricity is very important. So as we have seen, electricity led to high improvements in technology. So from here until now, we have seen several ways to transform energy from mechanical or from magnetic energy into electrical energy. And the basic invention that helped into electrical invention is the invention of the dynamo. The dynamo, which will convert the rotation, the mechanical rotation, into electricity generation. So as we have seen together, electricity is one of the most important and convenient form of energy, and it has enabled a lot of advances in sciences, making life much more comfortable. Production of electricity also started with hydroelectric power stations. So another form for producing electricity is hydroelectric power station. And as its name indicates, it will use flow, energy of the water flow in order to be converted to electrical power. Okay, so hydroelectric power stations started at the end of the 19th century, and they moved to coal-fired plants and nuclear plants. So of course, maybe coal-fired and nuclear plants can be more efficient, because you know that nuclear power can lead to a very large amount of energy. While if you want to rely on hydroelectric power stations, we need to build towers of very high height, because as we have seen in the formula, higher is the pressure head, so higher is the height from which water is falling, higher will be the energy and power produced. Now, nuclear power were considered as cheap, and they produce a lot of energy, but the issue is that safety is not very high in these systems, and multiple accidents of nuclear plants render their safety very questionable, and we try to reduce nuclear energy. And you know, one of the main accidents were in Fukushima and Chernobyl. So this is why we reduce the use of nuclear energy as a way to produce energy. And we will see together how mainly nuclear power function, and also how hydroelectric power stations function. So let us look first on hydroelectricity, how we can produce, and it's very simple, and mainly hydroelectricity is very similar to the concept of water wheels, because we will see in this video how you can first, you convert the energy of water, which can be potential energy or in the form of kinetic energy if you have a river. Then this energy of water will be transformed into rotational mechanical energy of a water wheel or of a turbine, and then the turbine will be related to a generator to produce electricity. So let us look at this. So this is a very small device, and you will see how it is used to produce electricity. So the concept is very simple. As you will see here, it's called a very small power generator. So we can see how it's functioning here. So all you have to do, you have, for example, here a flow of the river. So you have kinetic energy of water that can be transformed into mechanical energy. All you have to do is to place your device here. So let us see it here. So we place the device where we have a flow of water, and then the flow of water will rotate the blades, and the blades are connected to a generator, because you know that rotational motion is transformed in a generator to electrical field. So as you can see here, okay, the flow of water here, they are doing manually this, but when you put it in water, it will automatically, you will have the change of kinetic energy of water into rotation of this device. And then you have a built-in inside, you have a generator, because the rotation of the axis will be transmitted to a generator, and the generator will lead to production of electricity. So you can use the small device to light lamps on the streets. Okay, and here you have the scheme of how it's functioning. So you have the flow of water. Here you can have let's say a river, and the flow of water. So you have the kinetic energy of water that will lead to the rotation of the blades, and then this rotation is transmitted to the generator, which main function is to transform the rotational energy into electrical energy. So you can use this application to, as we said, to light the lamp streets, or to have production of small power electricity. So as you can see here, it will be used to light the lamp. So this is a small application of hydroelectricity. Of course, you can have this on very large plants. So you have sometimes towers where you will store water, and of course another application is dams. So you will store water, and then you will keep them at very high elevation, and when you need to use them, you will have the flow of water from very high levels. Therefore, the potential energy will be transformed into kinetic energy first of water, which can rotate turbine blades, and from the turbine through the generator you can produce electricity. Now, for nuclear power stations, we will see a small sample of a nuclear power device. So here you can see the main component of a nuclear reactor. Okay, so to start with, you have several components. Okay, so let us see here. Okay. So mainly, you have several components of your system. You have the reactor, you have a pump, a heat exchanger, and then you have steam that will be ejected on a turbine in order to rotate. Okay? Now, we will look at the main component of the nuclear reactor. The nuclear reactor is based on the following principle. I can induce fissions of atoms, and these fissions will produce a very high thermal energy. Then this thermal energy will be used to heat water and produce steam. And once I produce steam, the pressure of the high pressure steam energy will be transformed into mechanical energy that will rotate the turbine. Okay. Now here's the idea how to produce the high nuclear energy. So we will look at the main components of my system. So first you have this is the nuclear reactor. Okay, the nuclear reactor has fuel elements first. So as you can see here, these are the fuel elements. Okay, the fuel elements are elements containing material like uranium. Okay, that can be easily divided into small neutrons, and this will produce energy. Okay, so the fuel elements are in the form of rods, as you can see, about nearly 1 centimeter in diameter, and they contain fissionable nuclei as uranium. Now, what we will do is by just putting a small neutron into contact with the fuel elements, we will have fission reactions, and these reactions will lead to production of high energy, because as it will lead to the formation of new neutrons characterized by a very high energy. Okay, and then the very high energy neutrons will be slowed down, as you will see, by a moderator, because if they are at very high velocity, they will escape. Okay, so we will see now that in addition to the fuel elements, we have what is called a moderator, which can be any fluid. Mainly it's water. In general, we use water, and the main function of water is to slow down the neutrons produced by the fission in the reactor. Okay, so you will see here that if you have a certain neutron of small energy, after fission you will produce neutrons of very high energy, and in order to avoid them to escape, we should slow them down. This is done by the moderator, because as they will be produced, they will encounter molecules of water that will slow them down. Okay, and if you want to control the rate of fission you have in your reactor, you can add what is called the control rods. Okay, so you can add, as you can see here, these are control rods. The control rods will, if you want, it will absorb the excess of neutrons produced. And if you want to accelerate the rate of fissions you have, you can remove the rods. So in this way, you can control the rate of fissions in your reactor. Now, as we have said, fissions produced will lead to very high amount of energy. So neutrons will give you a large amount of thermal energy. Therefore, you can heat water. Okay, so when you produce this thermal energy, you have water circulating in your system, because we will see here that you have, so if we just go little, so here just you can see how when you have neutrons that are moving at very high velocity, water will prevent them, will slow them down, and the rods can absorb the excess of neutrons if you want to slow down the rate of fission. Okay, now if we look to the circuit again, you can see here that you have the pump. The main function of the pump is to circulate water between the nuclear reactor and a heat exchanger. In the heat exchanger, you have any fluid here, so it can be water. So in general, we use water both in the reactor and in the heat exchanger. Okay, so here pump will circulate water between these elements, and when leaving the reactor, water will leave at very high temperature. Okay, then it can be used to heat water in this reservoir here, and once heated enough, you will have production of steam, and the steam produced, the power of the steam produced will be transmitted to the turbine. So energy will be transmitted from steam, which is a thermal energy and pressure energy, into a rotational energy. And of course, the rotation of the turbine can be then transferred to electrical energy. So another application for transformation of energy is the nuclear reactor. Any question? Please stop me if you don't understand.
Yes, Dr. Fihada, he's waiting for you to let him in. He got logged out and he can't access.
Okay. Sorry. Yeah.
Thank you.
Welcome. Okay. So let us go back to the slides.
Professor, I just have one question regarding the control rods.
Yes.
Do you know what material is it made from, the control rod?
Yes, you can have cadmium. Okay, one of the possibility. You have several materials, but one of them is cadmium. Okay.
Okay, so they are not affected by the neutrons.
No, of course.
Oh, okay, thank you.
Were the rods effective in Fukushima?
Maybe they didn't use rods. So
Okay.
because it's an option, you can remove them. Okay.
Because I read
you have a lot of safety issues that you should take into consideration. So the reactor is, in general, we put it in a very thick concrete wall. Okay, to avoid a very high thermal leakage, because if you have a very high thermal leakage, this can be dangerous. Okay, so you should take a lot of safety issues when using nuclear reactors. And this is why we don't rely a lot on nuclear energy. Yani we are trying to avoid these systems and rely on other types of energy.
Do we have a way to get rid of the waste from these plants?
You can, yes, you can use the waste energy again. So this is a very important technique to increase the efficiency, because in general, we will learn that you can never completely convert heat into work. Okay, but in order to increase the efficiency of any system, any heat that is lost can be collected again and used, for example, to heat another fluid. So you will increase the efficiency of your system because you will benefit even from your losses. And we will see that in some devices, the released heat will be used again in the same system. Okay? This is called preheating. So you can use it to reheat again.
Yes.
Okay, so we will continue in the history of energy technology. So Edison built the first power station in London, which produced 160 kilowatts of electric power for public lighting and electric motors. The following year, he built a similar station in New York City to provide electric lighting. And please, you don't have to remember any date. It's just small information for you to be introduced to the course, okay? Just you should understand the concepts we are talking about. Now, Thomas Westinghouse later built an alternating current system as opposed to the direct current of Edison. So you know, in electricity, you have mainly two types of current, alternating and direct current. Alternating current will be variable with time, okay? While direct current will be stable, so you don't have variation with time. So, so here we have two opposing trends, but the alternating current system proved superior and was adopted worldwide due to its ability to use transformers to raise the voltage as the level of power produced increased. So with time, the need for electricity increased. This is why we need a very high power from electricity. The first large-scale electric power plant was built on the US side of the Niagara Falls using Fourneron turbines. So one of the important application of 4-Néron turbines is production of electricity. The 20th century witnessed a massive construction program of coal-fired power stations using steam turbines and hydroelectric plants. The most significant development was then the development of nuclear power for electricity generation in the second half of 1950. So in all of these techniques, we are using several systems, and the main purpose is to convert a form of energy into electrical energy. Now, renewable energy came back to light after the Israel-Arab war, which resulted in oil price shocks. So, you know, as we advance in time, the need for energy is increasing, and we have shortcuts in oil and fuel storage. This is why after, and mainly after the Israel-Arab war, we had a lot of increase in oil price. This is why people begin to think about other types of energy to use, and we have development of research programs that were funded by variable countries in order to come up with alternative energy technologies with the main aim reducing the dependence on oil, because we don't have a lot of reserves and we need a lot of energy. So if we continue like this, we will not have any more reserves and we cannot produce energy. So we should develop other tracks in energy. From here, we begin to do research in wind power, solar power, which were gaining a lot of support as the effects of global warming were reduced. And we will see in detail what is global warming. And these techniques become more pronounced, as well as the fossil fuels reserves become uneconomic to extract, because we will see that we have reserves at a level close to the earth, and we have other reserves that are very deep in earth. So, and more the reserves are deep, you have a high economical level to extract them. Okay, so the energy consumption to extract them become very high, so their prices will rise, of course. So in modern society, we need to become more dependent on energy availability and on the use of free and renewable energy as wind power and solar power. Now, as you can see in this graph, we represent the variation of energy production and consumption using several types of energy, the product that will give us energy. As for example, you have nuclear power, gas power, oil power, coal power, hydropower, and all of these types, the trend is the same for all of these types. For all of these types, the energy consumption is increasing, and it's very largely increasing after 1960. So after the Industrial Revolution, we have a very high rate of increase in all of types of energy consumption, and also in their cost, because higher the need, higher will be the cost of these techniques. Now, it's true that with advances in technology and energy production, the quality of life improved a lot due to the breakthrough of other areas, because technology will lead to advances in medicine and food and a lot of issues. Okay, but we should also take into consideration the negative effects on the environment. So we have observed that with time, the temperature of the earth is increasing and the pollution is increasing. Okay, so we need energy, but we don't want the negative effect of energy, which is a complex problem. From here, we started to think about ways to produce energy that will not be harmful for the environment. Okay, and this is mainly renewable energy. So as we can see here, in the worldwide, the global energy trends are very similar, and of course, especially in developed countries. So for developed countries, we have a very high consumption of energy. So the total energy demand is expected to grow by 40% from 12,000 million of tons of oil equivalent. What is MTOE? It's million of tons of oil equivalent, and this is a unit of energy used to describe the energy content of all fuels, typically on a very large scale. And it is equal to a very high number, to 4.1868 times 10 to the power 16 joules. Okay, so we are expecting to have an increase of 40% of energy from 12,000 millions of tons of oil equivalent to 16,500 MTOE by 2030. So energy produced by fossil fuels will increase by 30%, with a shift away from coal to gas because of its availability and its lower carbon intensity emission. Okay, but we should try also to go to new technologies in order to reduce our production from fossil fuels, because as we have seen, they have bad impact, and the reserves are being depleted with time. So electricity generation is expected also to increase by nearly 65%, from 20,000 terawatt hour in 2008 to 35,000 terawatt hour in 2030. So it's a huge increase in electricity consumption. And currently, nearly the share of electricity generation in 2008 here was 3%. So we are only using 3% of renewable energy in order to the portion to produce electricity, and this is a very small amount. Okay, so we should rely on renewable energy in the production of a higher amount of electrical energy. So we are expecting that we can reach 10% of electricity production using renewable energy by 2030, and higher is this amount with time, better will be, because we will reduce the negative effects of fuel combustion and global warming effects. And we will detail next week, we will detail what is global warming and how we can reduce it. So we will stop for today. Okay, I will post for you this chapter. It's recorded, and I will post for you the links, the YouTube links. Try to go over them, and if you have any question, you can ask me